And I- I've been going through your CV. I've been going through your profile as well, and that's not stalking, but I just saw that you've been having that chaos testing principles talk in Slovakia. How did it went?
It went pretty well. So thanks for introducing me first. It went pretty well. I think everyone wants to test on production systems. But the problem is production system is the place where all the business takes place. So if anything breaks down there, it is not only a financial loss, but it is also a reputational loss. Right.
Makes sense.
And the problem with us testers is we build confidence into those systems which we test. So we test on the staging environments. So if my test pass, that means the staging is working perfectly fine. But as soon as the staging data and code goes to the production through all the pipelines, and then something will definitely happen there. So it's a controversial thing, but again, people took it very openly. I explained the strategies, how to convince the boss, what exactly you need to put into your test plan, how to minimize the losses, still doing some testing there. So I think good questions came in the end, and I think I got good reviews. So I'm happy.
Excellent. And correct me if I'm wrong. I always say that testers are the last filter before delivering the product or the item to the end user or to the product team or to anyone else. That signifies the importance of testing in general.
That is true.
So Vipin, today we're gonna telling us about the common testing strategies to test Internet of Things for various industries. And yeah, I believe that this stage is yours right now. You can start whenever you are ready.
Thank you. Let me share my screen and just let me know if you can see the screen.
Yes, we can see it, and it would be great if you could like spread it all over the screen.
Yeah, of course. I'll be just playing it. Right from beginning. Is this fine?
Oh, good. Yeah, thank you.
Oops, perfectly fine. Okay. So hello all. So thanks for having me here. It's a new group for me, new set of people. And that's why I like this talk even more, because I'm talking to completely strangers, let's say. But I'm sure that after this talk, we'll be connected, we'll stay connected for long. Fine. So I'm 25, 26 years experience now. Last 20 years is all dedicated into software testing. And I've seen testing has changed shapes, changed, I would say, importance. 10 years ago, testers were always considered as a second generation people or second world people. Everything is about developers. Developers are doing this, developers are doing that. Tester is just an activity. But over the time, with the systems becoming more complex, the importance of testers has increased a lot, right? We are no more developing ASP websites. Now we are working with AI, machine learnings. There are robotics, IoT is everywhere, right? We talk about connected cars, we talk about connected systems. They work fine. And they work fine because good testing has been performed. Having said that, yes, there are issues. There will be issues that are found and fixed. Developers still hold the key of delivering a software, but testers are the stakeholders, are the key holders who ensure that things go out fine, tested, correct. That's something in general. Now coming to the topic, IoT is my, you can say, love after my job. I love study about IoT. And about 2016, I bought my first smartwatch. Two questions immediately come to my mind. A, why it is called as a smartwatch? It's a digital watch, yes, but why smart? And then I had a smart TV. You may have a smart washing machine, a smart house, a smart car. So why this word smart? Because I'm from the age where smart means I should look good, right? My hair is neatly combed. nice shirt, trousers, belt, shoes. So overall, you look smart. But how the devices are getting smarter? There is a smart washing machine and there is a non-smart washing machine, both put in front of you, or a smart TV or non-smart TV, both put in front of you. You watch the same things on it, right? The channels work fine. So why smart? So that question came to my mind. And the second question was, how can I ensure that the number of steps that I walked today is the exact number of steps that my watch is also showing? So if my watch says I have walked 5,000 steps today, I never counted. So how to test it? Do I have to walk 5,000 steps and then continuously seeing my watch, whether it is showing correct number of steps? And then what would happen if I'm climbing up or if I'm climbing down? Number of steps and the difference between two steps also changes. How the watch is keeping track of it. So as a tester, the questions keep on coming. When I was driving with my cousin in US in a Tesla car, I was sitting on the back seat and I was again thinking as a tester, what would happen if the car decides not to take a turn where it's supposed to be take a turn? It will just crash. Developer can say, oh, sorry, there was a bug. The tester can say, oh, sorry, I couldn't find the bug, but then someone may have died. So IoT systems or AI or robotics, these are very, I would say, great technologies that humankind have developed. But the problem is the challenges they pose for the developers and the tester is equally huge, because the cost of failure of one test case here might be a difference between the life and death. It is not a test case failing on Amazon where someone can use your credit card and buy stuff without asking you, which is a fraud. But that's a financial loss. You will still be alive. You can still fight a case or go to police and complain about this. But if a Tesla car crashes, or if a pacemaker in the heart it crashes, a patient may die. So I started learning about all this, and then I realized that IoT is really something that I have now developed love about. And also, a lot of people come to me and they ask, like, we want to test IoT, but we don't know how to begin. And that actually led me write this paper, because IoT is quite active in lots of different domains: pharmaceuticals, manufacturing, real-time systems. And people also ask, like, okay, I have tested IoT in pharmaceutical sector. If I go to agriculture, do I have to test IoT in a different way? So this paper, this presentation is about identifying and looking at some common strategies to test IoT for various industries. Let's move forward. First, see why we have to do or we have to learn about IoT testing. So the important thing here is, if you see this graph, it's between 2015 and to 2025. The red color bars are basically the number of IoT devices which are increasing. So from 3.8 billion in 2015, it is expected to reach 21.5, which is approximately 7 times the number in 2015. So in 10 years, number of IoTized devices or connected or smart devices is expected to jump by 7 times. The white bars here are the non-IoTized devices like your mobiles, iPads, and other stuff. They are also increasing, but if you just see from 10.1, it only expected to increase 12.7. That's like much less as compared to the IoTized devices. And when I talk in terms of the number of devices, so what's the business value of these? So 2017, it was $170 billion. The business was there. And it grew $560 plus billion in 2022. It should reach about $800 billion by 2025. This is a huge amount. This can be a GDP of many countries of the world. You as a tester or you as a company owner, you cannot stay away from this amount. At least get some amount out of this huge thing. Get a pie, get a piece of cake from this big cake. So because of these financial reasons, also you may start think of doing IoT testing. Now, how IoT is becoming more and more popular, it's not a new thing now. It's already at our houses. Smart homes, wearables, smart city, grids, internet, farming, supply chain, retail, health, connected cars. You name any domain and IoT is there. So which means if you are not doing, still there are hundreds of companies, hundreds of developers and testers are actually doing IoT development and testing. What is fueling this IoT revolution? Now, this is very interesting. And I always use this slide in many of my presentations to make people understand how in last 10, 12 years, these things have suddenly become very, very popular. If you are a tester, like for last 15 or 18 years, you can relate to it like from 2000 till 2008 or 2010, AI testing, robotic testing, IoT testing. These are the words which are always used to be the future testings. But last 10 years, suddenly everyone is talking about, I want to do AI testing. We want AI testers. We want ML testers. We want IoT testers. How it has happened in 10 years. So just see, first thing, the electronics, it gets smaller, powerful, cheaper, and widely available. The number of mobiles sold across the world in the first decade of this century, compare that with the number of mobiles sold in the second decade. I guess everyone in this world, practically everyone, has at least one mobile in his hand, and that has to be a smartphone. And even the smartphones, the cost 5 years ago is compared to today, the cost is have gone down. The mobiles have become very strong. You don't need to buy a particular brand for the strength. Even the smaller brands or less popular brands also have developed mobiles which are equally strong. They are widely available with everyone. And then we are small, so you can actually put it into your pockets. That's first thing. The second thing is internet infrastructure has become very matured and very strong around the world. So gone are the days where you say that, oh, I'm going to US and let's say the internet is good. And I go to UK and internet is not so good. And I go to Spain, the internet is perfect. And you go to India, internet is very weak. Now these things are not there. You go to anywhere and you will have internet, 4Gs, 5Gs available. So internet is very, very popular. So now you have a phone in your hand, which is available and cheaper and smaller. And then you have a very strong internet infrastructure to support that kind of communication. And lastly, IoT is primarily made up of lots of sensors. And when I say lots, it means billions of sensors. So one sensor is a small device. And to individually identify a device, it needs to be given an IP address. When there are billions and billions of devices, how we can give individual identifiers to them? To do this, IPv6 was adopted, which increased the number of available identifiers from 4.3 billion to 3.4 into 10 to the power 38 addresses. Now, I cannot speak this word 3.4 followed by 38 zeros. I know how many trillions, billions, millions. I don't know. But a simple analogy is, if every atom on this earth is given an individual IP address, out of this 3.4 into 10 to the power 38, still you are left with that number of identifiers, which is sufficient to give atoms on few more planets. So now you can realize like what this number is. So every identifier, every device has a unique identifier. There is a huge internet infrastructure and the availability of devices that has actually made this IoT evolution, which I also call as a revolution, because IoT cannot work if internet is not there, because it produces data in real time. And of course, you should have devices in your hand so that the data gets processed and it comes back to on your mobile screens. So this is how it is increasing. So it is again estimated that the devices, there are about 7 devices per person in this world. The world population is about 7 billion, and it will the number of devices will increase very fast. What exactly is IoT? We have talked about everything. So this diagram explains everything. There is a dashboard which is present on your mobile or handheld. There is a cloud, right? And then there are devices which are connected to the cloud. So very simply, if I put it, all the devices, the smartphone, smart houses, smart watch, it is producing data and it is pushing this data into somewhere in the clouds. Lots of machine learning and pattern matching algorithms are working there, and they produce a lot of interesting information from that data. And that information is pushed back onto your mobile devices. And all this is possible with an internet infrastructure. If internet breaks down or doesn't work, the data doesn't get pushed on the cloud and it doesn't get calculated and pushed back on your devices. This is a simple definition from the Google. As a tester now, I'll give you a small use case so that you also start thinking about how to test IoT. This is a coffee machine. It is a non-IoTized coffee machine, which is basically the machine that we see everywhere, right? If you want to drink a coffee from this machine, what are the steps that you will take? The user goes to the dispenser. You select the preferred option. You want to drink cappuccino or latte or Americano or what? You put a cup under the nozzle, whichever coffee you prefer. The drink comes out because you press that and you enjoy the drink, right? This happens today. Tomorrow you go, follow the exact 5 steps, enjoy your drink. 2 years later, you go, execute these 5 steps, you get the same drink. You keep on going, it is producing the same result every time. Same experience will be available to you every time. There is no change. Cappuccino, same taste, same amount every time. That is our normal testing. But when I go in front of an IoTized coffee machine, and there are IoTized coffee machine in real, what all happens there? First, they have to bring dynamic UX, which is important. That's why the importance of UI, UX developers have increased a lot. And second, they have to produce valuable data. Because IoT means IoT works on data. It produces data, it consumes data. This is a model of that. So the machine in the center, that is your coffee machine. When you go in front of the machine, it captures your photo. The photo is sent to a cloud, like the step number 1. A pattern matching happens where your face image is matched against millions of faces that are present in the so you accept your persona. As soon as you accept it, all the data which is associated with your persona, it comes back, which means how many times you have taken coffee, which coffees you have taken. Monday, you have taken Americano. On Tuesday, you go for cappuccino. On Friday, you go for a light coffee. And this is happening. So the machine can now say, hey, Vipin, welcome. It's Monday. Do you want to have your regular Americano? And you are suddenly like, wow. And then you are instantly connected with the machine. It's a personalized experience to you. And whatever data you provide today, like, okay, it's Monday, but I want to go for a latte. So that data goes back to the customer, to the cloud, stores there, and continuously this process happens. And the processing is happening continuously. So the machine is learning with every of your action. Right? So that is the machine learning things that we all talk about these days. And the machine continuously learns and evolve, learn and evolve. So next time when you go to the coffee machine, it gives you more options. Hey, Vipin, do you want to have your regular Americano? But last Monday, you got a latte. So what exactly you want to do? So the machine knows everything about you. And what are the data that we collect from this coffee machine example? We collect the context, technology, camera, sensors, the demography, country, state, city, where you are in. Are you in a mall, office, or restaurant? What is the season? Summer, spring, fall, winter, time of the day, weekday, weekend, holidays, is it a one user or there is a long queue? Because when you go in a long queue and you reach to the coffee machine, you are already tired, frustrated. Similarly, the weather, if it is too hot outside, you may want a different coffee. If it is too cold, you may want a different coffee. Then mall, office, restaurant. So what is your mood? Basically, it collects your mood. Then it also collects your persona. Kid, young, senior, the age groups, male, female, happy, sad, angry. What is your mood? The interactions, the display options as per the persona. So that means every time you have a different experience based on the data that you provide. So if you compare this with the previous coffee machine, you don't have choices of type of data that you want to provide. So you always get the same experience, but here you get different experience. But this difference is possible only with the collected data, right? So sensors produce data, and then you need cloud to push all the data. Then you need machine learning and artificial intelligence to actually work on that data and find interesting patterns out of it. And then you need a strong internet infrastructure to send those patterns back to the machines. This is how IoT works in general. But then what are the challenges? IoT is not a single thing. It is a combination of hardware, it is software, and connectivity. The problem is we need to test everything. So we are either a software testers, or we are a hardware testers, or we are network testers. But this is the first technology which asks us to test everything as a whole. So your end-to-end testing is not just about software, from hardware till the softwares and the connectivity, and two devices talk to each other. So the protocols testing needs to be done. There are millions of APIs that are working because they ensure that smooth communication happens, a smooth handshake happens between two different devices. Compatibility testing is important here because if a device fails and you replace it with some another device from a different company, we have to make sure that this new device from a new company will be compatible with all the other devices in the network. So that's the challenge. We might be strong in software testing, but we don't know about hardware testing. So we have to learn everything. What has changed from the normal testing and into IoT testing? The process has changed because first, data is coming from all the directions. In my previous testing, data generally comes from 2 or 3 directions. Either user enters the data into your forms and the data goes inside, or the data is written in some Excels and then they need to be imported, or the data comes from, let's say, some live stream. But here you cannot stop the users from using these devices anywhere in the world, which means data can come from any side. The tests have to be carried out in the field as against the test labs. Like the smartwatch example I took, I actually have to run sometimes in the field, slow, fast, walk, and then see how my watch is responding. And similarly, there are more users need to be considered while testing. More user experience needs to be considered while testing. Then you also have to find different people to test the smart devices. For example, dedicated runners for fitness tracking test. I don't run, I don't jog. So if someone asks me to test it and I start running, after I think 20 or 50 steps, I will be done. So which means I am not a suitable candidate for checking a fitness tracking devices. Similarly, if you need to test a pacemaker, a heart pacemaker as an IoT device, you actually need to find a patient because you need to inject that device inside the person and connect it with the heart. And then you have to track it. Like if the patient is running, what is his heartbeat? If the patient is sitting, what is his heartbeat? If he's shouting, if he's angry, if he's anxious, what is his heartbeat? So to do this, you actually have to find a person. This is a second type. And finally, you also need to work with subject matter experts who know how to track heartbeats. So, okay, my device is saying my heartbeat is 92, but I need a medical doctor who can use the stethoscope, apply to my heart, and then see, yes, Vipin, this is 92. Because if the test fails, you know what can happen, right? Similarly, if a device fails within a system, a patient's body, he again needs to undergo a surgery. So you need to go to doctors and ask that, please operate on him, get this device out and put another device in. You are not putting the device in your pocket. You are actually putting the device inside your body. So a normal IT person cannot fix that. You need to have subject matter experts, doctors, runners, and all this kind of stuff. This is an example how a test case looks like in IoT thing. If you see the step number 4, have the test subject begin jogging, maintaining a 6 to 8 minute mile pace for 30 minutes. Maintain proximity about 15 minutes to test the subject using motorized vehicle and reading of the motorized vehicle. And then the results, like, so someone is running and then there is a motorized vehicle running, driving in parallel of him. So they are those who can measure the speed actually from the air. These things are used in a lot of sports, right? So this is like a sample test case screenshot. Let's look at the challenges. So use cases have become complex. That is true. And the responsiveness needs to be real time. So if I'm, as I said, if I'm running, my watch should be updated immediately. It should not update like, let's say, 5 minutes. There cannot be a lag of time. It should be like a couple of seconds. So that's why I said internet infrastructure has become matured. And that's why this real-time responsiveness is becoming very, very crucial because of that. The performance needs for fast responses, that is true. Data security and privacy, oh yes. With this amount of data which gets produced, there has to be a lot of security and privacy testing required. Britain has GDPR. If you are testing anything there, they will ensure that the data which gets produced from their devices should be stored in clouds within their area, should be under the control of them. Otherwise, they will ask questions. What would happen if this data goes out? And this is very personalized data, a patient's data, right? You cannot make the patient's data publicly available. So your security and privacy testing becomes very crucial. Then you need to test protocols, MQTTs, XMPs, CoAPs. These are the protocols which are used for two devices to talk to each other. You have to support requirements for volume, variety, and veracity of data. We are not talking about few thousand records. We are talking about few million, billion records. So the volume of data, the variety of data that comes in, you have to provide support. And then diverse IoT apps and devices. IoT is not being created by one company. Hundreds of companies are making it. So when devices from different companies are put in a single ecosystem, they need to be tested and connected and protocols and everything. And then there are large number of sensor interactions. So again, the variety, right? So these are basically the reasons why the testing has to be scaled up. So we know these testings, right? But you have to apply all of them with the idea that what is the amount of data that you are actually dealing with. Now, if I move from, let's say, pharmaceutical to test, let's say, Tesla car, do I have to change my IoT testing approach or it remains same? Domains are different. So yes, you have to learn new things. The use cases in Tesla car will not work in pharmaceutical or hospital industry. But there are few test cases that I have identified, few types of testings, which remain same wherever you go. And to discuss about that, let me also tell you that IoT is made up of, these days, it is a 7-layered architecture. It started with 2 layers, it went to 3, but as the application becomes complex, the number of layers also increased. But for me, the most important 4 layers are the application layer, services layer, gateway and network layer, and the things where the real sensors are, sensor layer. So what are the testing types that you have to apply at application level? You have to do localization testing, API testing, functionality testing, and compatibility and usability testing. At service layers, you need to check interoperability. One device replaced by another device. You have to check the API testing, and you have to go about functionality testing. At gateway layers, you have to check network connectivity and you check network compatibility. If you move from 4G to broadband, what would happen? And finally, at the sensor layer, check the functional aspects check the security, which means I have to work on performance testing. I have to be strong in security testing. I should know about compliance testing. Compliance is very important because, as I said, if you are testing in UK, you have to apply by the GDPR rules. Different countries have different compliance rules, different regulatory rules. So you have to obey them. You have to be strong in interoperability testing, and finally, the privacy and analytics. So we are doing functional testing everywhere. We do automation and manual testings, regression, sanities, smoke testing, and all API testing, performance testing. But here, apart from these, there are other types of testings as well, which generally we don't do. So if my project does not talk about security, I don't do any security testing. But in IoT cases, you have to be fluent with these 5 types of testings, and these individual testings at different layers. I give you examples from my healthcare project where I'm working. I cannot show everything because of this regulatory things, but I try to get some information out of it. So for example, the usability testing. What is usability in a healthcare project? So the devices should be portable. I can move, let's say, one heart monitoring system to a different place and it should work fine. Devices should be smart to push notification, error messages, and warning. If the device in my heart is not working fine, messages should come instantly, and it should not rely on what mobile device you are using. So it should not be a case that the message shows perfectly fine on Android, but it is not showing fine on iOS. It should show complete correctly in any type of device. System should be able to log all events and push in the database. Notifications should be displayed on all type of computers and handheld devices, and usability for displaying data, processing it, and pushing from device should be tested. These are the usability testing. If you talk about security testing, I have already told you IoT is data intensive. So security is crucial. Data can be stolen. So data is not just present inside cloud. It moves from one device to another, from one internet provider to another. So there are hundreds of places where you can actually steal the data. Hackers can attack it. So you also have to ensure that the flows where the device, where the data moves, they should also work fine. Test for your encryption protection. UI should be password protected wherever possible. Healthcare project test approach, connective testing. So it is very crucial. System should be up all the times. It cannot go down because, as I said, if system goes down, a patient may die. Test the data transfers and message notifications. Test the system down conditions. Now, what would happen if the system is down? It should instantly move to manual monitoring. And once the system is up again, there has to be a system process where the manually collected data should be put inside the database again, so that all the data of a patient is stored at a single place. What about pilot testing? So sometimes lab testing backfires if put in the real-time situations. So system is exposed to limited number of users in real field, and then we can make this application more robust for production deployment. Performance testing, as I said, system should be scalable. So I can initially test for 2-3 users and then scale up to, let's say, 200 users. If it works fine, you can scale it up further. You have to ensure that the performance always remains the same. And similarly, important parameters like system usage, power usage, temperature, it should be diligently monitored. Compatibility testing, as I said, all the devices in the IoT ecosystem should be compatible in terms of operating system versions, browser types, device generations, communication modes like Bluetooth 2.0, 3.0, all other stuff. It should not give any problem if I change any of these. If I move from one phone to another, one operating system to another, one Bluetooth version to another, system should be up. System should be running fine real time. And finally, regulatory testing. I need to pass various regulatory and compliance checkpoints. And very important testing is upgrade your systems and then ensure that the rest of the system works fine. So IoT is a mesh of protocols, devices, OS, firmware, hardware, and network. So sometimes a new version of the mobile comes in, upgrade it, and then ensure the rest of the system works fine. A new device update comes in, update it. You need to keep doing these things. And automation is a very, very important aspect here. So in summary, IoT testing is difficult, I agree. And it should be derived from the system and architecture involved. So you have to be part of even the architecture discussions. And I think this is one very good example where we use the word shift left. So testers should begin as early as possible, but not within the agile. Go and discuss about the architecture if you can. If you have the knowledge, go and discuss the architecture. That will help you actually to devise very good test cases. It is more of a testing as a user approach rather than on requirements. The requirement is very simple. I should walk with a smartwatch and it should give me correct number of steps. But you have to use these scenarios as a user to actually test it. So here it is also said that this is, I'm not testing an experiment, I'm testing an experience. Choose the device as an end user and then note down all your experiences as a tester. Integration testing is a very crucial aspect because there are lots of connectivities here. So your integration and system testing becomes very crucial. It is challenging, yes, but it is also exciting. I always feel excited when I talk about IoT because I need to gain a lot of knowledge. I need to certify not just a single device or a single software or some screens. It's a combination of everything. So I might be very good at a software and firmware testing, but I don't know about protocols or devices. So there is a lot of learning involved. These are some QR codes for the images that I took. So if you want, you can just, those images come from some IoT-based articles. So if you scan these, you can definitely go to those articles and you can gain more knowledge about that. And in the end, we are the presenters of this particular, we are the writers of this particular presentation, me and my wife, but I got to present it. So that is there. And I'm done. Thank you for hearing me, and I'm open for any questions.
Yeah, thank you, Vipin. Thank you, Anuba, as well, for preparing this insightful document for our participants today. Thank you for the knowledgeable comments, strategies delivered, the common tasks at various layers, the examples you provided, the healthcare project you used to demonstrate the different types of tests, etc. So now moving on to the questions. I've been receiving some questions from the participants. Whenever you are ready, I can start with the first question.
Yeah, I'm ready.
Okay, so the first one is, how do you manage the immense data volume generated by Internet of Things devices in testing?
So of course, you need experts in your team who are quite habitual with working on large amount of data, and lots of data testing is required. So two type of issues happen with data testing in IoT devices. A, data is not sufficient enough for you. It's not generated properly. And B, data is generated properly, but while reaching the cloud systems, it was like malfunctioned in between and it got changed. So if the data produced is 12, but it is stored as 15, data is still there. Your algorithms still work on that data, but the results that are produced, the information that we gathered from that data is incorrect. So a lot of machine learning is involved here. We have some immensely accurate algorithms which got created, and they are not created in a day or two. It's an exercise that we are doing continuously for many months now. And with the same number of people, same set of people, I generally don't ask new people to join the team unless there is a requirement. Because anyone who is from day one in this project, I value them a lot. I make sure that they stay within the team because they know in and out of this system. I'm not against new people joining, but the problem is if someone comes now, he has to spend a whole lot of time to reach to a particular place where we all are. He has to understand all the algorithms and everything. So coming back to the question again, we create a lot of dummy data, first of all, to test all the algorithms which work on the real data correctly. We create a lot of situations where that dummy data gets produced and processed, and then the results are already planned. We know that, okay, these are the results which are coming. Excel and all these are out of questions because they all have limited set of data that is available. My golden data set in this case has like about 7.3 million records. Any new module that comes in, I run it on 7.3 million records. A lot of automation is involved here, and it still takes me about, I think, if I'm right, 43 minutes or something to run the first experiment and to show me that, yes, this new set of data that comes in is correct. Then the rest of the algorithms start beginning and they produce their own data. So as I said, is a combination of algorithms, machine learnings, and now I'm also exploring a lot of AI tools because AI suddenly got popular last year after this chat GPT, and everyone is talking about use AI to do your testing and other stuff. So we are exploring, but as you said, there are compliance and regulatory issues. If I give all the real-time data to AI, I don't know where that data can go. So I am very hesitant right now because pharmaceutical is very, very personal data. I cannot have this data available to anyone on AI. So those are the challenges, and that's how we tackle them.
Thank you for your insightful answer. And moving on to the second question. It reads, as the Internet of Things landscape continues to evolve, what emerging trends and technologies should testers be prepared to address their testing efforts?
Perfect. So the slide where I showed what are the types of testings you have to do, that's the first thing, right? I'm not talking about technologies. I'll that be the part B of my answer. But the part A is increase your testing database, increase your testing knowledge. Don't just rely on whatever you are doing right now or doing like for last 10 years. It's a common trend that if we are working in the same company for, let's say, last 5 years, we keep doing what we are doing. I'm an automation guy, I just write scripts. You are a manual guy, you just do the manual testing. But IoT testing is a blend of everything. And as I've shown, you cannot just rely on functional testings or API testing. So if you have not done performance testing, develop that skill. Learn a couple of tools. If you have not done security testing, learn the tricks, how to do security testing. If you have not done large database testing, and when I say large, it's like at least few million records, at least, right? Do that kind of testing. So first, be geared up, have all those tools with you. Then enter the technology aspect. So with the tools, you enter the technology. And then learn about AI. It's a must now. As I said, it has their own challenges, but you cannot say that I want to work in these kind of things, but I don't want to work with AI. AI has covered us from everywhere. More than AI, I would say machine learning will give you, I would say, a strong thing in your resume that you are good with lots of varieties of testing, machine learning, some AI, depending on if the company allows you or not using those AI tools. But machine learning, algorithms, pattern matchings, you have to do that. And to do that, you have to, again, expand your horizon, move out of the testing bubble, also become a little bit of developer if you are not already. Right? So start thinking from a developer perspective, because the algorithms, to test those algorithms, you have to understand them. And I cannot explain you those theoretically. That, okay, we do this, we do this, we do this, and the algorithm is gone. No, you have to apply various varieties of data to the algorithm to make sure you get the correct amount of data. So these are the things. So as I said, last 10 years, this ecosystem has developed. Devices, internet infrastructure, IoT, AI, machine learning, everything has actually collected together now. And big data, cloud, if you are not used to work on Salesforce systems, let's say, or the cloud databases, make yourself available, make yourself prepare for like how a cloud works. Many people who don't know, like it's like where the cloud is, where this data goes, because your security and your performance also depends on the cloud. Right? So lots of questions your stakeholders will ask you before even you start. How you ensure the security? Our data is in cloud. How will you ensure security? If you don't know how to put security in a cloud system, you have to learn it now. How the data gets processed, how fast it gets processed. IoT is all about real-time responsiveness. If you cannot prove that the performance testing has a lag time of, let's say, only half a second using tools and dashboards, then it's a challenge for you. So you cannot explain. So if any of you is a manager or who talks with customers directly or who adds business to the your organization, you have to be very fluent and very, I would say, accurate in your answers. And this accuracy can come not by learning from books. This accuracy actually come from your real-time usage, real-time practice of all these testing technologies and testing types.
Thank you. Thank you for your answer. So if you wanted to rephrase it, it's like gearing up on tools, leveraging and harnessing the power of AI, ML, like big data, Internet of Things and stuff, and moving out of the comfort zone of being an only tester and moving towards the spectrum of developing in order to like be able to compete and to be able to face the trends that are about to occur.
And that is precisely what shift left actually means. Shift left does not mean that testers should start its testing journey from the beginning of a project or product lifecycle. You actually shift left, put yourself into a developer's shoes, put yourself into a BA shoes, right? Because put yourself in an architect shoes. And then you actually start looking at the software end to end with a different perspective. And it will actually leads to creation of better test cases, I would say.
Yeah, that's a great like project management advice in here, as seeing things from different perspective always brings us the best out of anything that we are doing. And this is leading us to our final question in here, which is and I'm reading it. It's how can testers adapt to the ever-changing dynamics of Internet of Things environments? I believe you answered it partially, but if possible, yeah, expand on it.
I can repeat few statements and I can add few new. I think learning is definitely the one, right? All the statements that we say to our team members, our juniors, that, oh, guys, you should have learnability. You should learn new things. It's not just the juniors. We have to learn. Right? If we are learning, and again, as I said, not everyone can learn everything. It also is controlled by the companies you work in, the projects that you are part of, the projects you are responsible for. So if your project demands security testing, you will learn security testing. But if your goal is to go into IoT testing, let's say 2 years down the line or 3 years down the line, then you have to begin your learning from now. And that has to be outside your project time, right? I would say get addicted to something in a positive sense, not in a negative sense. But just the word addiction itself actually forces you to do few things, which generally you say, I don't have time. So if someone is addicted to watch movies, he will always find time to watch movie. If someone is a health freak, he wakes up early and he does all his exercising and running and everything. But if I'm not a health freak, I always have an excuse of not waking up early. Similarly, if you want to learn and you put learnability as an addiction, you will always learn. People ask me, I just turned 50 yesterday. And people ask me, oh, you are 50, you have a family to look after, you have few projects to deliver, and still you are going into conferences. This is my fifth conference in last 40 days. How you find time? How you find time? I said, I have a same 24-hour clock, just like anyone else. And then you travel so much, and then you write blogs. You are quite active on LinkedIn and everything. We want to do this, but we don't have time. And how you are able to do that? There is a time that you can find. I said, oh, God has given me a 36-hour clock. And for you, it's 24-hour clock. So it doesn't matter. I said, if you have a passion for doing something, you see what is the state you are in right now. Are you in a positive state of mind, or you are like fed up with your job and you are not in a, you are in some negative thoughts and other stuff? And then see where you actually want to yourself. And don't have a 5-year vision or a 10-year vision. Gone are the
Vipin, yes, apologies ahead. Technical
So I
issues
think the
in here.
good thing is the thing that I dreaded the most, that the network should not break in between my talk. As soon as the talk is over, it broke.
Yeah. Sorry about that. It just broke at the very end of our fruitful session. Sorry about that, and I'm pretty thankful for your insights, for your presentation, the one that you have prepared with your wife. And we are looking forward to meeting up again in another insightful sessions. We'll be leaving Vipin's details and LinkedIn profile in another post if you want to connect directly and go ahead with the questions and continue
Perfect.
this learning journey.
Perfect. Thanks, Hamza,
Thank
for
you.
having me talk to you guys. And as I said, I would love to have you guys one day have an in-person conference, and I would be the first person coming there. So
Yeah.
just keep doing these great things for community.
Hopefully we'll do. Thank you, Vipin.
Thank
Hoping
you. Thank you,
to see
everyone.
you again. Thank
See
you.
you. Bye.